We're going to do a severe weather spotter training course as well as talk about severe weather tonight. The National Weather Service, Clay from the GSP office, is actually on the stream as well. He's listening in. He's kind of going to be my check person to make sure I cover everything, because you're not only helping me, you're going to be helping the National Weather Service. So if you're not familiar with what the National Weather Service does, our local office actually isn't very local. It's down in Greer, South Carolina. Greer, South Carolina office covers Mecklenburg County, but the Columbia office actually covers Lancaster County, Chesterfield County, and to the southeast. Our eastern counties are covered by the Raleigh office, and a couple of my counties that are up in the mountains are actually covered by Blacksburg. So we have 4 separate offices, and not one of them is actually located in the TV market that I'm in right here in Charlotte. So it makes it kind of I would say difficult, but it makes it interesting because we have to communicate with a lot of offices outside the area, but they monitor a lot of what we do here in Charlotte. And just to show you, if you're looking at the graphics across the country, these weather service offices are the ones that are primarily going to be issuing your warnings. So the warnings, I know a lot of folks think I'm responsible for that. I can't take that responsibility. That would be, I wouldn't take the blame or the praise for that. But that actually comes from the National Weather Service. And the reason that is important, it's a government agency. They're the ones that are able to trigger all the EAS, the alerts, sirens, anything like that. So when your phone goes off, those wireless emergency alerts, it's because they issued it and it was able to go out. And just to kind of recap, that's the coverage area for the Greenville-Spartanburg area. Here's a look at our TV market. So if you're not familiar with the TV business, the Charlotte TV market covers 22 counties. So if you've ever wondered or yelled at me for breaking into programming, it's because one of these counties had a tornado warning, and it's kind of our responsibility to cover these counties. And we'll get yelled at a lot because we're covering a county that might be an hour and a half, 2-hour drive away. And a lot of folks will say, Brad, why are you cutting in? Nothing's happening in Charlotte. Well, I'm the TV station for Statesville, for Boone, for Hickory, for Rockingham, for Rock Hill, for all those cities. They rely on us for severe weather information. So as much as people in Charlotte might be upset I'm cutting in, they're glad. And vice versa. Think about it. There's a tornado warning in Charlotte. They're probably wondering, why are you breaking into my programming? Because nothing's happening here. But this is broken up between the 4 forecast offices. You can see I kind of color coded them there. I'll zoom in. And the biggest problem here, and I know Clay is listening, he can probably relate to this, is that little panhandle of Lancaster County, which shoots up 521. Believe it or not, we've had warnings for York County, no warning for Lancaster County, and then a warning for Union County, because those are actually 2 separate offices responsible. So they're working hard to coordinate these warnings. But a lot of times, if you watch my coverage, you might hear me say, just treat this like a warning. That's why I say that, because a lot of times, obviously tornadoes don't stop at the county line. They'll go wherever they want. Some of the tools we use for severe weather, believe it or not, I think people are always mystified by this. We still launch weather balloons twice a day, and they're not all from China. They're actually here, okay? We actually launch 2 times a day. The closest sounding location is in Greensboro, and the next closest is down in Atlanta. So what these weather balloons do is twice a day, we call it 0Z and 12Z. If you're familiar with Zulu time or UTC time, that's in the morning and in the evening. For us, Eastern time right now, that's approximately 7 a.m. and 7 p.m. Okay, and so on this balloon is a little package. It's like a weather station in a shoebox. It's called a radiosonde. It measures the air temperature, dew point pressure, and wind speed and direction from the ground up until that balloon pops. And as we got to see with the Chinese spy balloon, these balloons go up to the stratosphere. They will make it all the way up to 90, maybe 100,000 feet before they pop. They're made of latex, so what happens is as you go up, the pressure decreases, right? So the balloon will get bigger and bigger and bigger until it explodes. It also gets a little flatter as it gets bigger, which makes it look like what? A UFO. So over time, these things get higher up there. Eventually they'll explode. And they could be in the air for like 2.5, 3 hours. And they'll get carried long way in the jet stream. Sometimes they'll end up out in the Atlantic from here and go even farther. What's interesting is the radiosonde, which is the instrument pack, actually has a self-addressed stamped postage on the outside of it. And if you find one of these, because it eventually will fall back to Earth with a parachute, you throw it in a mailbox, it gets mailed back to the National Weather Service, and they recycle it. It actually says not a bomb on it as well, because a lot of people see this and they see government writing and they think it's something bad. But I can't remember. Clay could probably tell me. I wish he could hear me. Yeah, like how many did they get returned? He might know. I think it's like maybe 25 or 30%. I have to turn my audio up here. Whoa. Oh. I'm going to move this a little farther away. There we go. All right, Clay, I don't know if you can hear me, but how many of the radiosondes do you guys get returned? Do you know offhand, the Weather Service?
Yeah, so actually it's a really low number. We were under the impression it was kind of like 10% get returned from us. We were under the impression it was kind of like 10% get returned from us.
So it's about, he says it's about 10%, so it's even lower than I thought. And my guess would be that because a lot of them end up in areas where there's nobody to find them. Because you think about it, especially in North Carolina, they're probably ending out over the Atlantic. So those are really important. Obviously, you know about Doppler radar. We'll talk more about that in a minute. Satellite data has become really, really important. Our satellite data has become, to me, that's one of the biggest advancements in my 25 years of doing that, is that satellite data now can come in at 30 seconds to 1 minute intervals. So sometimes the satellite data comes in more frequently than the radar data, because the satellite, it's a geostationary satellite continuously anchored over the US. It can take a picture every 30 seconds to a minute, and it's high res capability. And the resolution is now down to tens of meters. So you can see a cumulus cloud, a thunderstorm developing on a satellite image before the rain actually shows up on the radar. It's pretty impressive. This morning, how many of you guys saw the Starship blow up down in Texas? Okay, SpaceX launched the Starship this morning and tested it. It blew up. First thing I did, I went to the GOES satellite data, and sure enough, I could see the plume and I could see the explosion on the satellite data. That's how good the satellite did. In fact, the satellite data thought it was a lightning strike, because the flash to the satellite looks like a flash of lightning. So it shows up. We sometimes see meteors that way as well. We use a lot of weather models. Weather models, I think everyone's heard of weather models, and people are like, what is a weather model? It's basically a giant math problem. It's a numerical model. These are simulations of the atmosphere into the future. They're not forecasts. I think that's the biggest misnomer. I think if you think it's a forecast, it's not. It's a tool. We call them guidance for a reason. They help us build a forecast. To me, it's like going to Lowe's or Home Depot. Just because you have a bunch of tools doesn't mean you can build a house, okay? You still got to put the thing together. There's lumber, there's nails, there's stuff. That's the stuff we use to put the forecast together. So these are tools. You just don't go there and pick out a house at Lowe's. You got to put the thing together. And so that's what we do. One of the great things about the Weather Service is, and you may have heard me refer to this on air as we're doing storm coverage, is we're in constant communication with emergency managers, the National Weather Service, even other meteorologists in the Charlotte TV market. We have a private chat, and we're chatting with them all the time, and we're sharing information about where storms are, where they could be going, if there's going to be a warning. If not, like, hey, I'll tell Clay and the guys down at GSP and Trish, like, hey, I see this storm on radar. It looks like it's rotating. Are you guys thinking about warning on it? And we'll have that kind of communication a lot through them. Doppler radar. Everybody's got Doppler radar on their phone. It looks cool. Not everybody knows how it works. I love Doppler radar, but I think the biggest thing that people misunderstand about it is it's got huge drawbacks. Doppler radar is essentially a tool like a cell phone tower. They are sporadically placed around the country. They don't have uniform coverage. So just like a cell phone tower, if you're not really close to it, your signal isn't really good. The farther you get away from the radar, the worse the data is. And that's why spotters become really important. So one of the things about Doppler radar is it shoots a pencil width beam of energy out, and it goes out in a straight line from the radar. But obviously the Earth it is not flat. If breaking news, in case you guys thought it was, it is a sphere. So because it's a sphere, the beam starts going higher and higher in the sky because it goes out in a straight line. The Earth actually curves away from it. So by the time the radar beam from Greer gets up here, depending on what part of town you are, it could be between 5,000 and 10,000 feet above our heads, okay? That's great. That's way up there. But guess where all the severe weather happens? Down here near the ground. So like things like tornadoes, downbursts, even hail size, you need to see closer to the ground. So spotters become really, really important. And that's why I really rely on spotters, because I can see the rotation at 10,000 feet, but I don't know if that's creating a tornado down at the surface. So somebody reporting or sending me a picture or sending me video is really, really valuable, especially if you know what you're looking at. The thing about Doppler radar that makes it so cool to me is it doesn't just tell us where things are, it tells us which direction they're going. So the Doppler effect is what Doppler radar uses. And you probably are familiar with the Doppler effect and you don't even know it. If you've been at a train crossing or you've been at a light and a fire truck comes by, the frequency of the sound coming towards you is different as it goes away. So imagine being at the train tracks and a train is coming in, it goes, it makes that change in sound and frequency. Well, we use that in the Doppler radar. When raindrops or targets are coming towards the radar, they have a different frequency than they go away. So not only can we tell where raindrops are on the map, we can tell if it's coming towards or away from the radar. And why is that important? Well, if raindrops going towards the radar and away are really close together, guess what's happening in between? You have rotation, you have things moving. So it's really important to know where that stuff is. Now, the Doppler radar doesn't just scan at one level. It goes through what's called a volume scan. It rotates around, tilts up, rotates around again, tilts up, rotates around, and it can do several slices of the atmosphere. And if you put them all together, you can get a 3D image of what a storm looks like. And if you're watching on the stream, you can see this is a 3D image of the velocity data of the Pilger tornadoes in Nebraska. I think it was like 6 years ago. 2 tornadoes next to each other, and that's what it looks like. We can see things like hail cores. It's pretty cool. Having chased storms, looking at these 3D images, it's kind of what the structure of a storm looks like. So here's a look at what the radar sees. You can see the radar scans different levels, as I mentioned, but below, it doesn't really see really well, and that's where the spotter becomes really important. So what we're looking for, what we want people to give us information is what is happening at the cloud base and below. This is a really, really important part. The farther away you get from the radar, we get even less and less data, as I mentioned. So in Charlotte, it's really helpful to have spotters, but I tell you what, spotters up in Statesville, Salisbury area, it's even more important because the radar beam there can be 12, 13,000 feet above the ground. So the spotters actually have a program called SKYWARN. They're the ones that help, kind of give ground truth to what's happening. And in some cases actually can lead to warnings being issued. If we know there are trained spotters in the area and they spot a wall cloud or a possible tornado, if we know these are trained spotters, the National Weather Service will issue a warning. They will count that as like an observed tornado. So that's how vital it is. We know it's a trained professional, basically not professional, not getting paid, unfortunately, but you're trained amateurs, I guess, in this case, that would help issue a warning. A lot of trained spotters also include first responders. So think of most law enforcement, firefighters, medic, they're all trained on this as well. They would count those as SKYWARN trained as well. So what is a severe thunderstorm warning? Okay. So severe thunderstorm warning. What was one to get issued for? Well, believe it or not, it's not because of dark clouds and loud thunder and lightning. A lot of times we think just because a storm has a ton of lightning and it's really loud or scary looking, it's severe. Sometimes I think it's a bad storm, but what makes it severe is actually specific criteria. 58-mile-per-hour winds or higher, okay? That's usually the threshold to break a branch or cause damage. 1-inch diameter hail. 1-inch diameter is the hail that's just below golf ball size. It's very close to that. That's the kind that will cause damage to your roof and your car, even if you can't see it. If you ever get golf ball size hail at your house, get your roof checked out as soon as possible, because you may not notice damage, but the next time it rains, you will know. You'll find out pretty quickly. And then obviously tornadoes. But there's other hazards like lightning and flooding. Flooding does have a warning system, obviously flash flood warnings, but lightning, as dangerous as lightning is, there's no criteria for a warning for the amounts of lightning. I wish there was, but there really isn't. So, one storm that has more lightning than the other is definitely, I think, in my opinion, a more violent storm because that means a lot of updraft is going on. We've got a lot of things going on, but there's no criteria for lightning that would trigger a warning, even though we want you to take all lightning very seriously. So the risk levels, you probably have seen these in other locations. The Storm Prediction Center puts these out way ahead of time. We call these severe weather outlooks. They go from 1 to 5. I'll be honest with you, and I know Clay's listening, so he'll understand. We know the public doesn't really understand this very well. We have colors and names that people don't associate with bad weather. Things like marginal, slight, enhanced, moderate. People don't always relate to bad weather. So what we have done, and this is what we do as broadcasters and to help communicate it better, is we've kind of grouped them into more simplistic terms and more simplistic colors. We use low, medium, high, and extreme. It's pretty straightforward. Yellow, orange, red, and then kind of a pink color. And that's kind of the thresholds we use. And again, this is just a heads up. Think of a severe weather outlook as a heads up, days and days ahead of time. So oftentimes you'll see me use this graphic on air. It's a 5-day severe weather outlook. I'll say maybe Tuesday, Wednesday, Thursday, Friday, Saturday on there. You know, we'll say one of those days, there's a potential, a low, medium, or high risk for severe weather. This is kind of the beginning, like, hey, heads up, this is not going to be a normal day. There's not just going to be regular thunderstorms. And this is what it looks like. If you go to the storm prediction site, the center site, they actually go out to 8 days. So believe it or not, we get 8 days into the future. We kind of have a general idea where there could be severe weather. And the way this works, think of it as a forecast funnel. 8 days out, the area is really broad. We think somewhere in the Carolinas, there's going to be severe weather. 3 to 4 days out, we might narrow it down to the Western Carolinas. And then the day of, there might be a watch issued for just some of the counties in there. And then if there's a warning, it's down to the county level. So it starts broad in a time scale and a geographic standpoint and gets closer and closer to, you know, a town or a home. But the thing to remember too is you can get severe weather in any risk level. Some of the worst tornado days here have been in what is considered low to medium risk days. It's, you know, we'd love to say every high risk day produces a ton of severe weather, but some of the low end days produce it as well. That's why any risk level, you got to take it seriously. Watch first warning. How many people know what a watch and a warning are? All right, most of you do, but this is still the most confusing thing that we talk about. I have people I work with that get it confused, you know, and sometimes I'll see a horrible headline or we'll put a super up and it'll say tornado warning from 1 to 5 p.m. And I'm like, what? How is there a 4-hour tornado warning? It was meant to be a tornado watch. Okay, a watch is up for hours. It's the ingredients are there. The warning is a more immediate, like in the next 20 to 30 minutes. So I'm going to go forward here quickly. I left it out. So you might have seen my cupcake analogy, right? So I like to use the cupcake analogy. The watch is like having all the ingredients for the cupcakes on the counter. The warning is the cupcake's made. Okay. So when a watch is issued, that means the ingredients for that thing is on the table. Once we get a warning, that means it's put together. So a flood watch means conditions are favorable for flooding. Tornado watch means conditions are favorable for tornadoes. Winter storm watch means conditions are favorable for winter weather. Once the warning is issued, that means, guess what? The ingredients came together, it got baked, and it's sitting on the table. It's there. So the warning is the more immediate threat. There are several types of warnings now. We have base warnings, considerable warnings, and destructive warnings. So severe thunderstorms even have different criteria. And the considerable means 70-mile-per-hour winds or higher. So this means it's not just a regular severe thunderstorm. This is going to be pretty dangerous. And if we get a destructive tag on there, which is 80-mile-per-hour winds or baseball-sized hail, this will actually set your phone off. You'll get one of those wireless emergency alerts. And if you're not familiar with these wireless emergency alerts, it's not an app on your phone. It's built into your phone, and it comes from the cell phone carrier. It's like the EAS on our TV stations. It comes across whether you want it or not. Now, you can turn them on and off in the operating system, iOS and in Android. I would recommend not doing that because these are the most severe of severe. We don't push these out for regular severe thunderstorm warnings, even considerable. They have to be destructive. They have to be flash flood warnings or a tornado warning. And the way they work, I wish they were totally GPS based, They're really not. They're based on the cell phone tower you're hitting. So I see 2 cell phone towers over here. Imagine, we're pretty close, but imagine that cell phone tower is in a tornado warning, but for some reason over here at lower left, we weren't. We would get the tornado warning because the cell phone tower we're hitting is inside the tornado warning. So it's based off the cell phone tower that your phone is receiving from. So there tends to be a little bit of overwarning, but not as much as there would be if we just issued for the whole county. This is a really loud alert, and I'm not going to mimic on here because we can't, but we've had them go off in the station before while we've been on TV, and it is super loud. There's also amber alerts on there as well, and those will go off quite a bit. Got to be careful of those because those are issued on the statewide level. And I'll be honest with you, I want to find every kid, but sometimes you get an amber alert for somewhere that's not anywhere near you. And for a lot of reasons, that's how people end up turning all their alerts off because the amber alerts set them off all the time. And so you can distinguish, you can turn just amber alerts off and leave the weather alerts on. So there is the option, at least in iOS, I know. I'm not sure about Android. I haven't looked. I don't know, James, you would know. Can you have the option in Android too? I know in iOS you do. So that being said, I think everybody should have 3 ways to get warnings. Okay. Severe weather warnings you should have 3 sources. Wireless emergency alerts built into your phone, weather apps like ours, WCNC, but there are a bevy of other apps that will warn you. Watching TV or monitoring TV or live streams. I'll be honest with you, and James can attest to this because he's my streaming guy. We get more people that watch the stream. And the reason is we can send a notification to your phone and you're more likely to click that link and watch the live stream immediately and not go over to the TV and turn it on. Social media is great. As we know, Twitter is kind of getting wonky now for warnings. There's limits on the API now, so I would not rely on Twitter as much as I would in the past, but it is a source. You can turn notifications on for certain warnings. Same thing with Facebook, Instagram. There's some other sources that aren't bad. Social media tends to be better for the heads up days ahead of time than the actual warnings. Other things, NOAA weather radio. Does anyone here have a NOAA weather radio? Yeah. NOAA weather radios are great. The phone's kind of making them obsolete, but they are great for especially areas where you don't have cell phone coverage because you can usually get radio coverage. The other thing, this is surprising, we find in research, people calling, texting family and friends actually works. And believe it or not, they're more likely to believe their family and friends tell them there's a tornado warning than me. That's just human nature. And so I will say this on the air all the time. You guys, I know you watch a lot of your avid viewers of mine. You may have friends, family, colleagues that don't watch me, but if I can warn you and then you can warn them, then the process is working. So if you know, like, hey, my buddy lives in Gastonia or somebody I go to church with lives in Statesville and there's a tornado warning, I can easily pick up my phone and text them or call them and say, hey, do you know there's a tornado warning right now for where you are? They may not, and it might be your text or call that actually gives them the heads up. So don't ever hesitate to do that. That is a valuable tool. What you do is amplify our message. It goes out to a few people. You tell your friends, they tell their friends, and it just spreads the message much quicker. So this is the graphic I was looking for earlier. This is my cupcake watch and cupcake warning. I'll leave that up for a second because I made this like 7 years ago just on a whim. I think I was running and I thought of this. And I had so many emergency managers reach out to me and say, hey, can we use your graphic? I'm like, sure, whatever makes people understand. And so many people saw it and got it right away. So if this helps at all, the watch and warning thing it really is difficult. So tornadoes, we're in that season right now. Tornado average by month for the US, April, May, and June are the 3 biggest months. May is by far the biggest month. Let's talk about North Carolina though. The average tornado by month, March, April, May, and then September. Does anyone know why September would be a big month in the Carolinas for tornadoes? Hurricanes. Exactly. Landfalling tropical storms and hurricanes. So we have a secondary season in the fall. And we also get pretty strong cold fronts that time of year. But for us, we're kind of in the heart of tornado time, April and May. Biggest tornado outbreaks I've seen here have been in April, May, and then October, September. Hurricane Fred, Francis, some of these landfalling hurricanes that come up from the Florida Panhandle tend to be big tornado producers for us. But we do get tornadoes here. How many people ever told you that we don't get tornadoes here? Yeah. I don't know. Is it like a real estate agent thing that like to get to sell house? Or I mean, because I newcomers all the time will say, "Oh, I heard we didn't get tornadoes here," and I'm like, "Who told you that?" And just to show you, and it's not that I try to scare people. I'm like, they think somehow that they don't happen here. They do happen quite a bit. So you may have heard recently, where is Tornado Alley? Tornado Alley, is it in the middle of the country or the southeast? Well, Tornado Alley, there's really not one. There's lots of them. And if anything, the tornado pattern is shifting east with time. And unfortunately, it's shifting in our direction. So I wanted to show North Carolina tornadoes. I love this website. If you're really into tornadoes and you're really geeked out like me, this tornado archive site is amazing. It shows every tornado that they can document since 1680. And you're like, how do they know tornadoes from 1680? They went back and they looked at like stories, writings, newspaper articles of people talking about twisters or cyclones. And they tried to document tornadoes that occurred in the past. And then all the ones that have been documented by the Weather Service. But look at North Carolina and South Carolina. We have a ton of tornadoes. And I want to zoom in on Mecklenburg County. I'm going to leave this graphic up because it'll take a second to load on your phone. But look at all of those tornadoes in the metro. Did you guys know there was an EF4 that went through Western Union County in the early 90s? I looked at that tornado track quite a bit. Back in the early 90s, Western Union County was just farms. If that same tornado occurred today, it would be taking out $250,000 million homes, shopping centers, and several schools. Our area is growing rapidly. The tornadoes that occurred in the past, which we have documentation of, if they occurred today, there's millions and millions of dollars of property and now people living in areas where there would be nothing 20, 30 years ago. So as our urban sprawl continues to move out, we become bigger targets for these tornadoes. It's not that tornadoes don't hit cities. You hear that quite a bit from people. It's just that cities are small points on a map. They're hard to hit. But as they get bigger, they become easier. So there's a tornado that went not too far from here back in, it was the early 2000s, actually came through the airport, hit Johnson C. Smith, and then went into Dilworth and just north of here in South Bend. So there's the reason I say this is there's a history of tornadoes occurring here. It's just sometimes you go through lulls in the activity and people don't remember them and they think they don't happen anymore. So severe thunderstorms, let's talk a little bit about them. How do they form? The biggest thing to think about severe weather, we need lift and you need instability or thunderstorm fuel. Thunderstorm fuel is just warm, moist air near the surface. The lift is a cold front, low pressure, heating of the day, something like that lifts the storm. There's thunderstorm stages. Hopefully we get this to work. But if you could see this image on your phone, this is a really important image. I think the one thing I could tell people about thunderstorms is they're not static things. Like a lot of times in the summer, I'll get countless messages about why do storms always go around my house? I get this all the time. And everyone thinks that they live in a bubble, like the storms never come. And the thing is, I would say maybe that's true, but I get that same question from literally every single location in our area. So it's got to storm somewhere. But the reason I often say that when a storm is mature, when it's going crazy, that's in its mature stage. So when you hear or see a storm in the distance and think, oh, it's coming this way, guess what? It's already fallen apart before it's moving your direction. So storms have to be at their mature stage over your house. They're either growing, they're mature, or they're weakening. They're not static. So what happens over time is people will hear, especially in the summer, or see the lightning off in the distance, or they'll pull out their phone and see it on the radar, and then it'll never come to their house, and I think it missed him. But the problem was when they were looking at it, it was in the mature stage. And when it was coming, it dissipated. What's more likely is that storm will collapse, push out outflow, and a new storm will pop up over you. This is a cool little graphic I'll play about how these thunderstorms work. So oftentimes in the summer in particular, we'll wake up, it'll be a day like this. It'll be beautifully sunny in the morning and people will wonder, why is there a chance for severe weather? It's because above our heads, we've got wind shear, we've got warm, humid air. We just haven't lifted the air to get up there yet. And so what happens in the heating of the day, about 3, 4, 5 o'clock in the afternoon, those storms start to bubble up and we start tapping into those ingredients above our head. Certain types of storms, I don't know if we can even really see that, but there's something there at least. There's a couple different types of storms. We have single cell and multi-cell storms. A lot of times around here, we get what's called multi-cell. We get a bunch of little storms that all kind of form together. Single cells are pretty straightforward. It's a single storm. But one of the biggest things we see around here from damage isn't really from tornadoes. It's from downbursts. So downbursts happen quite a bit. Downbursts in the summertime in particular, we lift that warm, humid air up to a part of the atmosphere where the temperature could be 30, 40 below zero. That air gets cold and it becomes dense. And so it wants to come crashing back to the ground. And so what happens is it comes down at a wind speed of 70, 80, 100 miles an hour, hits the ground and spreads out in all directions. These downbursts or wet microbursts cause 90% of our wind damage here. So every time I see damage and people say it's a tornado, 9 times out of 10, it's not. It's straight line wind damage. And the thing to remember, straight line wind damage, we have a saying, wind is wind. Wind is going to break things. It doesn't matter if it's rotating or straight, okay? If your house, your structure, this tree can only withstand a 70 mile an hour wind, it doesn't care if it's a rotating wind or a straight line wind. It just cares it's 70 miles an hour. And trust me, airline pilots don't care either. These downbursts, before the advent of Doppler radar, believe it or not, planes used to crash all the time trying to land in thunderstorms because the thunderstorm would push the plane down into the ground as it was trying to land or take off. And so if you ever wonder why there's so many delays in the summer because of thunderstorms, it's probably the worst time to travel, because what happens is when these storms are anywhere near the airport, there's not a plane taking off or landing. And the other thing is when there's thunderstorms near the airport, if there's lightning, think about all the ground crews. Are you going to be out filling a plane up with fuel when there's thunder and lightning on the tarmac? Probably not. So what do they got to do? All the baggage carriers and the fuelers, they all have to seek shelter until the lightning's gone. So that will also shut the airport down. So if you ever get frustrated with thunderstorms in the summer and travel, it's because we've kind of learned our lesson in the past. They do not mess with thunderstorms. So downburst, I think this video works. I'll play it. You'll probably hear some audio on your end. But there's a cool animation I'm going to play here of a downburst. It shows a thunderstorm development. And from a spotter standpoint, downbursts are really cool because when they come down to the ground, you can actually see them hit the ground and you'll see things curl up on either end. It looks like a bell. And when you see that curling, you know the wind is actually pulling out. So there's a picture up there, but on your phone, you'll see it as well, of that downburst happening. It looks like a waterfall. The rain just crashes to the ground and causes the wind to push out in all directions. We kind of like jokingly call these splats because on the radar, it looks like someone just took a bunch of wind and threw it straight down on a flat surface and it just splats and it goes all over. And the direction on there's a great picture right here, this animation here. It actually just looks like the air crashing to the ground. And you'll see these little curly cues on the end, which is a really good example of a downburst. The other type of storms we get here quite a bit are squall lines. This is what we like to call the straight line storms. It looks like a long line of storms. This is more typical of what people see on the radar and they go, uh-oh, something's coming. Because this is the kind of thing that will go on for a long time. You'll see these over in Tennessee or coming out of the mountains, and you can track these hours into the future. These are basically clusters of storms that form on cold fronts or outflows, and they go for hours, but they produce a lot of strong winds. The squall line structure is basically, there's still that mature stage going on. What's happening when storms are maintaining themselves, new storms are forming on the front as old ones die in the back, and they're going through a cycle where new storms are continually building and old ones are dying out. Storm motion kind of looks like that. You got a nice little flow. The other type of squall line, which you've probably heard, is called a derecho. A derecho is a long-lived wind event. We've seen some of these in the Carolinas. There's been many more in the Midwest. They're very common in the summer season, and they kind of ride around those big ridges of heat and high pressure in the summer. A derecho, by definition, means it has a large area of wind damage of 58 mile per hour winds or higher over a 250 mile long path. So these things, when I lived in the Midwest, you would see these come through the Great Lakes, and they would just knock down huge swaths of trees. The big one in Iowa, I think it was now 3 years ago, was basically the equivalent of an inland hurricane. It produced 140, 150 mile an hour winds all through Iowa and caused all kinds of damage. These can happen in the middle of the night too, which makes them kind of scary because they just go forever. And the probably most famous type of thunderstorm, which is the one that gets all the publicity and gets all the glamour, is the supercell. The supercell is the storm that produces tornadoes. This is your classic hook echo, and the cells we see most often in the plains. We do see them here in the Carolinas, but they look a little different. They're not always classic. They are individual storms all by themselves. And what makes them supercells is they have rotating updrafts. The rotating updraft is what makes them dangerous. The structure of a supercell is, to me, it's actually a really beautiful structure. And if you ever get a chance to go storm chasing, just seeing one of these out in the plains is pretty spectacular because you can see everything in this graphic. I've seen it in real life. It's like something out of a textbook. And when you see it in the sky, it all makes sense because you can see the updraft, the downdraft, the mesocyclone, which is the rotating updraft. You can see the leading edge. Sometimes you'll see the wall cloud and the tornado coming out of the back, but the structure is really, really easy to see. We'll see if we can get this to work. I might pull this back a little. So if you're on the phone, there's this amazing animation I pulled up, and I'm gonna let it play out here. If it'll play, come on. There it goes. So this is a simulation of an EF5 tornado forming. It's a computer animation of real data. And it's probably not going to play now that I say this. Let me see if it'll play. Come on. Oh, here we go. So this really shows kind of the formation of a supercell and its then ensuing tornado. The supercells can be the size of the whole county. So imagine a storm that's the size of all Mecklenburg County. The supercell's updraft can not only drive wind into the high atmosphere, sometimes into the stratosphere. We'll get what's called stratospheric intrusion with the updraft, and that can actually bring down really strong winds to the surface. So think about that's sometimes 80, 90,000 feet into the sky. And then the mesocyclone will produce a tornado. The tornado is really tiny in comparison to this big storm. The tornado is only maybe half a football field wide, and the storm is taking up the whole county. So you can see on the graphic, it's pretty impressive to see that little tornado kind of forming underneath the mesocyclone. Now, the way tornadoes really get their power is they take broad circulations and they shrink them. That vorticity shrinking drives the speed of the tornado. So if anyone ever played tetherball? Okay. You know the cool thing about, all right, you played tetherball. What happens when the rope gets really short on the pole? It goes faster, doesn't it? Right? Okay. This happens in Mother Nature as well. If you take a broad circulation and start shrinking it down, it spins faster and faster. This is how figure skaters do those incredible spins. You might see them. They'll start their spin and they'll pull their arms in and they'll get really narrow and it'll make them spin faster and faster. This is the conservation of angular momentum. It causes things to spin faster. So in Mother Nature, the whole thunderstorm's rotating, and if it shrinks that rotation down to the size of the tornado, it spins at 100, 200, 300 miles an hour. So that kind of rotation can be pretty intense, and that's when you see these violent tornadoes. Types of supercells, low precipitation supercells. We don't get many of those here in the Carolinas just because it's so humid. These happen in the high plains, like think of eastern Colorado, New Mexico, Wyoming. These are beautiful storms to photograph because there's not much rain. There's just this beautiful structure. The tornado may be all by itself, and might not be any rain. Sometimes I've just seen hail in a tornado and no rain come out of these because the air is so dry. We typically get what's called high precipitation supercells. Those are pretty self-explanatory. I think if you've ever driven in a summer thunderstorm, everything feels like a high precipitation supercell because these are the types that have that tremendous rainfall rates, and usually the tornadoes are wrapped in rain. You can't see a thing. And that's why tornadoes here, I'd love to chase tornadoes, but here in the Carolinas, they're impossible to see because first of all, there's trees and hills, and then they're all rain wrapped. So sometimes it looks like a dark cloud, and all of a sudden you realize it's a tornado by the time it's over you. So chasing here is really hard. These are very common. Classic supercells, we do get these here in the Carolinas, but sometimes we get supercells embedded in squall lines. This is way more frequent. There will be a squall line, and within the squall line will be an embedded supercell. This can make for some really tough forecasts because you might have a big severe thunderstorm warning, and then inside you might have a tornado warning because we're starting to see these individual rotations. Sometimes on the leading edge of these squall lines, we'll actually have a couplet or a tornado. So just because it's a squall line doesn't mean we couldn't see rotation in it, and it does happen quite a bit. I've seen these quite a bit here in the Carolinas, mini low top supercells. These are small little storms that don't look like they're doing anything, and they'll produce tornadoes. This happens a lot this time of year in the spring and in the fall. We'll get these mini little supercells. So here's a graphic that kind of shows all of these different types of supercells. I wish it was straightforward. We could just tell you, here's one type of storm. Now, these are all the kinds that we get, and all of them, you really don't know if they're a supercell unless you look at the radar data and the velocity data together, and you can see that's rotating. What makes it a supercell is a rotating updraft. And you can't really tell that without looking at radar. Here's some actual pictures of supercells from some chasers, and then the tornadoes they produced. So they are pretty amazing. If you've ever seen like the mothership kind of view, this looks like a giant spacecraft landing. That's usually a supercell thunderstorm, and it's got that mothership is actually the mesocyclone. That's the rotating updraft. There actually will be striations in it sometimes. Here's a little diagram, kind of shows what it looks like. The other thing about these supercells is they have this phenomenon on the backside called the RFD, or the rear flank downdraft. When you take all that warm, humid air and push it up to the top of the storm, it's got to come back down. And sometimes it comes out of the back as a very strong downburst called the rear flank downdraft, or RFD. And that can cause more damage than a tornado, to be honest with you. So a wall cloud, these are things I would want you guys to spot if you ever see one of these. What's a wall cloud? Well, a wall cloud is kind of a lowering underneath that rotating updraft. Sometimes wall clouds are tough to see. You can't really tell if it's just a low-hanging cloud, but usually it's because it's persistent that you know it's a wall cloud. It's not transient, which means it's not there for a while and goes away. It's there, and it's the only thing. The base of the cloud is flat except for this little thing hanging down. Wall clouds are important because that's the precursor to a tornado forming. So when we see, or I get a report of a wall cloud, I'm going to be hyper-focused on that storm immediately. So a funnel cloud, I think that's pretty self-explanatory. A funnel cloud is obviously, it's a rotating column of air, but it's not in contact with the ground. I think when you see funnel clouds, it's not necessarily a tornado yet, but it could be. It could be touching the ground eventually, but if it's not, it's a funnel cloud. And the only way you know it's not touching the ground, you got to see all the way to the ground. So the other problem around spotting here, I might see a funnel cloud and trees are blocking my view of the ground. I have no idea if it's touching the ground. So if you were to report that, be honest, say, hey, I see a funnel cloud, but I can't tell if it's touching the ground. This is the direction I'm looking. Tornado, pretty self-explanatory. It's got to be in contact with the ground. It's redundant to say a tornado is on the ground because that's the definition of a tornado. It's on the ground. If it's not on the ground, then it's a funnel cloud. So they're two different things. Sometimes tornadoes, though, don't look like they're on the ground, except that you look down at the surface and you see debris swirling around. One of the first tornadoes I ever saw was in Ohio, and we didn't even know it was a tornado at first. We saw the wall cloud. I saw it was in one of those mini supercells coming at us. The base of the wall cloud was rotating. We're like, ooh, this thing's going to produce a tornado. And it was coming right at us, and we were idiots because we were in the wrong spot. But it was coming at us because we're thinking, oh, this thing might produce a tornado. Well, it was in the spring, so we had a freshly plowed soybean field. It was just dirt. Well, when it moved over this field, all of a sudden, there was a funnel there, and it filled full of dirt, and it became this big, dark tornado. The thing is, remember, a tornado is just a rotating column of air. If there's nothing in the air to see, you can't see it. So if it's really dry, you don't get a condensation funnel. Sometimes it takes debris to go into there for you to see it. So we realized right away that was a tornado the whole time. It just didn't have any debris to make it visible. So always look at the ground. I've seen tornadoes that are rotating up here. It's invisible. And then at the ground, you see a bunch of stuff swirling around. That's a tornado. They can be detached. Rotating wall cloud usually comes first, funnel cloud, and then tornado. That's usually the process. So that's why the wall cloud and funnel cloud are important. The whole point of us warning for tornadoes, is to tell you before they form. Tornado warnings, believe it or not, there's like a 70 to 75% false alarm rate. And that sounds really bad, right? The problem is you're trying to forecast that the tornado is happening. You don't always know for sure. That's sometimes a reflection of we don't have good data near the ground because of the radar, but also because we see the rotating storm, we see a wall cloud, and so we issue a warning in anticipation that there's going to be a tornado, and sometimes it doesn't happen. So the whole point is to forecast a tornado. So you're going to overwarn for tornadoes in most cases. You'd much rather have a false alarm rate than have the probability of detection be low, which means you didn't warn for actual tornado on the ground. So we have a high false alarm rate, but most tornadoes do not go unwarned. It still happens, but it's pretty rare, especially in this day and age. So just some tornado genesis process animations here, kind of show you how it works. So the way tornadoes typically form is we have a lot of strong wind shear, and wind shear is wind changing direction with height. So at the ground where we are on a day where I think there's going to be tornadoes, the winds could be coming from the south. But if you go up to 10,000 feet, the winds could be coming from the southwest or the west. So the wind is changing direction with height. Now, if it's clear, that's not a big deal. But if you get one of these thunderstorms that go up to 30,000 feet, now the thunderstorm is impacted by that changing wind direction. It causes the whole thunderstorm to rotate. And that's what creates the updraft that rotates and creates a supercell. And then you get the whole process of that rotation getting tighter and tighter and working its way down to the surface. So here's a quick animation of how that process works. Down at the ground, we might have strong surface winds. Aloft, we get these horizontal rolls developing, and then the updraft comes in and rotates that column on its end, and we get a wall cloud and then a tornado. So the two main ingredients, if there's a big tornado day, I can tell you two ingredients that will be off the charts: wind shear and that thunderstorm fuel, the cape, because that's the updraft. Those two things, those are the days we have the worst tornado risk. So in the spring, that's the worst time of year because the jet stream's really strong still. So we've got a ton of wind shear. And then we're starting to see these days like today where it's 85, 86 degrees. Only thing we didn't have today is humidity. It's really dry. It's beautiful out right now. It's not muggy. So if it was a really hot, humid day and we had wind shear with a cold front approaching, then tornadoes would be a big issue, which actually happened last night in Oklahoma City. That storm produced like 9 tornadoes south of Oklahoma City. So the way a radar looks on radar, you can see the rotation on radar, but with modern Doppler radar, we can actually confirm a tornado's on the ground. How do we do that? The radar, unfortunately, can actually pick up the debris that's being picked up by the tornado. So oftentimes the worst, it's like to me, watching the radar is sometimes can be really scary. Back in Mississippi last month, I was watching this rotation on the radar and it went through this town of Armour, and I could see the reflectivity jump up. And the reason you could see it was because parts of houses were showing up on the radar. Because the radar beam bounces effectively off a 2x4 shingles insulation. And you can see that on the radar, and you know right away that there's stuff being picked up. And that's a scary sight on the radar. And sometimes you can see the debris lofted to 15, 20, 25,000 feet, which tells you how strong the tornado is. So yeah, you can confirm a tornado with modern Doppler radar. Unfortunately, that doesn't do a lot of good because, the people it's hitting, it's impacting, but you can warn people in the next county or the next town over. And so a lot of times people are like, why do you want damage pictures and videos? Or why do you want these reports? Well, yeah, we might not be able to help the people that were impacted there, but this is going to help somebody the next county over seek shelter, because human nature is you like to confirm your threat. And confirmation isn't me on TV saying there's a tornado warning. I wish it was. It honestly isn't. What is more confirmation is somebody seeing a picture of a house destroyed, the tornado actually on the screen, or something happening. Then it becomes real to people. Otherwise, it looks like the radar looks like spilled paint on the map to them. And let's be honest, if you don't know what you're looking at, you don't know what to be scared about. It's like looking at an x-ray. Your doctor has to tell you, this is bad. And it's like, well, yeah, this is not looking good. I'm going to skip this one because it's not planned too well, but whoops.
Is it purple after it goes red?
What's that? The tornado?
The radar, on the radar. It's green,
So-
yellow, orange.
Yeah, it basically what happens on the radar when you get a tornado, you get red and green, bright colors next to each other. That's the velocity, but the reflectivity gets really bright, like really heavy rain, because it's not heavy rain or sleet or hail. It's actually objects. So it'll have a really bright return. So the tornadoes are rated on the EF scale from 0 to 5. So the weakest tornadoes are EF 0, the strongest are EF 5. Thank goodness EF 5 tornadoes only make up 1% of all tornadoes. So those monster tornadoes that you see, that are devastating towns, those are horrible, but they're very, very rare. Those are the type of storms that are on the ground for 2 or 3 hours. Think of Moore, Oklahoma, Xenia, Ohio, Joplin, Missouri, Tuscaloosa, Alabama. I could name a ton. Most of ours are the 0, 1, 2 scale. It's important to know that the EF scale is not something you can do in real time. It's a damage assessment. You have to look at the damage after the fact to rate the tornado. And the way they're rated is they use a combination of engineering and meteorologists. So you go out and you look at storm damage and you see, okay, this was a cedar tree, it was debarked, or it's a oak tree and it was bent over. We know structurally and engineering wise the physics of what it takes to do that to a tree, and you can calculate the wind speed. You look at a building, is it a cinder block building? Is it a mobile home? Is it a frame building? Then you know what kind of damage it does. Is there scarring of the ground? So there's these damage indicators that help us figure out what the actual damage was. Here's an image that shows a large tornado. Even within a large tornado, there might be different damage indicators within it. You might have EF 0 damage and EF 5 damage all in the same path. Tornadoes are really interesting because we get 1,300 a year in the United States on average, which is more than any other country in the world combined. We live in the tornado capital of the world. In fact, people from other countries come here to study tornadoes because we get so many. So it's unique to the United States. We don't get these many tornadoes in any other country. And it's just because our geography. If you think about the geography of North America, we have continuous land to the Arctic. We have continuous land to a tropical body of water, the Gulf of Mexico. And in between, we have 2 mountain chains on either side of the country. And it funnels everything into the middle of the continental United States, and we get tornadoes. So tornado safety. I preach this all the time. I do this every school talk I go to. I preach this. Where's the best place to be in a tornado? Oh, the most interior room in the middle of your house. Okay, as many walls between you and the outside. This is a weird statement, but it's not the wind that we're worried about. It's what the wind picks up and throws at you. So unlike the Wizard of Oz and Twister, it's very unlikely you're going to get sucked up by the tornado and carried to Kansas. What is more likely is something is going to get picked up and hit you in the head. Okay, 80% of fatalities in tornado are head trauma. It means you get hit in the head with something. So what we want to do, those walls block the debris from hitting you. If you're in the lowest floor of your house, people don't think of this, but the ceilings and floors above you are walls as well. They protect you from above. So they're layers of protection. And then lastly, we want you to have a helmet. Okay, bike helmet, skateboard, I don't care, motorcycle, any kind of hard hat, doesn't matter. Whatever protects your head from falling is going to protect your head from stuff hitting you. And that's where my job comes in. So days ahead of time, when I say, Thursday's a day to be weather aware, right? You hear me say that. That means it's a day to go get the helmets, clean out the closet, and put them in there. That's kind of what we do in our house. I mean, I'll go clean the closet out. We might have tornadoes. Just in case, throw the helmets in there. And that way, when the average tornado warning is only about 11 minutes, in 11 minutes, you don't want everyone to look around, what do we do or where do we go? You should already know. You should just go and do it. So that interior room, and the reason that interior room is really important is it's not just something we say. If you're looking at the graphic, this happened with the storms that just occurred in Mississippi as well. I see the damage and it's devastating. And my eye is completely drawn to a building where the interior room is the only room still standing. And I see it all the time. There's a picture right here. This is from Oklahoma. Interior room, the only one standing. That's a survivable room. Bathrooms are great. Half baths. because the plumbing in that room is usually anchored into the foundation or the slab or the basement. And those pipes will actually keep that room intact more so than another room. So half baths on the first floor are really good. Staircases are really well done in the middle of the house. All those load bearing walls, the more of them you have in the middle, the better, because those are the most protective rooms. So definitely do that. Other things to bring in there, bring your charger and your phone, because you're going to want to watch the coverage. And I'm going to do this more and more. This is something we don't do enough. Tell you when to leave. Go to that room and then, okay, coast is clear, come out. We don't do that well enough. That's been my goal for the last couple of years, is to give people more the all clear. Because when we had the tornado back in 2020, in that February one, you guys remember that? I went from like Pineville to Matthews, actually went through my backyard. I heard these horror stories of people in Uptown, like in the stairwell for 2 hours. Like, what were you in the stairwell for 2? They heard a tornado warning, and just stood in there and waited and waited. I'm like, well, at some point, it's over, right? But I guess because there's not enough all clear signals given, right? Schools, some of the schools, they were in there doing their right thing. They were in their safety location, but they were there for like an hour and a half. Tornado was gone like an hour ago. And people, so we're going to do more of that. One of the things to think about too, and I think more and more, is make sure you have a pair of shoes in there. And you're like, why do I need a pair of shoes? Well, if your house is damaged or destroyed, you're going to be climbing out through nails, broken glass, whatever. Don't be in bare feet. Have a pair of shoes, because a lot of injuries happen after the tornado because of debris. People get electrocuted, they step on nails, they cut themselves. And remember, those things may not seem that serious, but first responders are not going to be able to come and stitch you up right away. They're going to be responding to a lot of other things. So getting help for a simple injury might be a much bigger task after a tornado. So don't put yourself in a situation where that could happen. So this is a big thing I want to focus on, are tornado lookalikes. Okay. I get so many pictures of tornadoes that are just scud clouds. Everyone thinks every low-hanging dark cloud is a tornado. And 90% of the time, it's not. I like to call them SLCs, scary-looking clouds. Scary-looking clouds are all what they really are. There's low-hanging clouds. You got to remember, when it's really hot and humid and there's thunderstorms, there's a lot of up and down motion in that storm. So clouds are always going to be moving up and down. That's we call thunderstorms convection, because it's a convection current. You expect that. What we're looking for is things rotating horizontally very close together and rapidly. So things slowly moving around aren't that really big a deal. Think about it. If it's moving slow, that's not that what's the wind speed? 10, 15 miles an hour? It's not. If it's dangerous, it's going to be moving at highway speeds or faster. So think about that. And some of the things we see, a lot of the steam from the nuclear power plants, on certain days when the steam cloud gets up and connects to a cloud, we'll get tons of reports. There's a tornado at the lake. It's been there for 4 hours. It's like, yeah, I guess it's a steam cloud coming from the cooling towers. And the other thing, it's like, oh, it's just water vapor. It's just a cooling tower. So it's not all that dangerous. The other thing is sometimes smoke from a fire will go up and people will see the smoke plume, and we call them smoke nados because people think it's a tornado. But you see stuff like that a lot. In the mountains, you see sometimes those wispy clouds coming off the mountains after a heavy rain. Those little fracas clouds, we call them, sometimes get mistaken for tornadoes. So the biggest thing is to watch it. Is it rotating violently? Then you know it's a tornado. And the best thing to do is, in that situation, video is much more valuable than a still picture, because I can't see movement in a still picture. I could see a cloud that looks like a wedge and it's gone like a second later. You can't detect that in a picture. Any still picture can look like a tornado pretty easily. The thing that helps is the video. So if you can, send video clips so people can see if it's rotating or not. The other thing is, things need to, not that it doesn't happen, it's pretty rare. All tornadoes typically rotate clockwise or counterclockwise. So think of a counterclockwise spin. If it's spinning clockwise, which is rare, we call that, anticyclonic. That's kind of rare. But if you see that, that's probably not a tornado. Some other things that are pretty cool, and you see a lot of these here, shelf clouds. These shelf clouds are amazing, right? And you've seen these. It looks like a giant wall of clouds coming. This comes with these big thunderstorms in the summer, where cool air rushes out and meets warm air, which lifts up. It looks like a wave coming at you. This really looks like an Independence Day cloud, right? If you ever saw the movie, it's like this giant wall. These can be really scary looking, and sometimes they can be severe. They can be an indication of really strong straight line winds, but a lot of times they're not. It's really not all that bad. You've seen a lot of viral videos online of these. Sometimes they produce these little fingers. For some reason, grocery store parking lots tend to be a popular location for scary clouds, but people spend most time chasing in the planes. You just got to go to the local Publix and take pictures of clouds, because that's apparently where they all are. But these shelf clouds are pretty ominous looking. And this is how they form. I think I animated this. Let me see if I animate. So a shelf cloud is essentially cool, dry air coming out of the back and the warm, humid air going up and over it. So that's the process that's forming that. It's basically the cool air is forcing the warm air up, and it's creating the cloud. And that happens quite a bit around here. Other clouds to look at: downburst, shelf clouds, wall clouds, scud. Believe it or not, that one in the corner there, that's the kind of picture I get where people are like, that's a tornado. No, it's not a tornado. It's a scud cloud. It's just a scud. Those things will be moving all over the place sometimes too. And even trained spotters can be tricked. The whole point of that is, like, don't look at it for first glance. Take some time to watch it. And then you'll know, like, oh, it might dissipate in 3 or 4 seconds. And then you're like, oh, I guess that wasn't a tornado. But scud clouds are the most common thing I see around here, where people just mistake them. So hail, I was going to do a hail demonstration. Maybe I can do it now. So hail is pretty cool. Hey, can you hold this mic for me?
That's what I'm here for.
All right. I'm going to yell really loud so you guys can hear me. Everyone who wondered why this leaf blower was here, this is why it's here. Okay. So hail is pretty.
Am I going to get hurt?
Yeah. You have liability? No. Yeah. So thanks. So the way hail forms is pretty cool. I'm always fascinated by hail, and that the fact that it only can happen in the summertime, really. To think about that, it could be 90 degrees at the ground, and you could have hail coming down. It kind of blows people's minds. But the way it happens is you need moisture that's liquid at the bottom of the cloud to get blown up to a part of the storm where it's cold enough to freeze. The ice will freeze. It'll fall down and get wet again, get blown back up, get another layer of ice, come down, get wet again, and get blown back up, get another layer of ice. It'll go through this convection current as many times until the hail's big enough where the updraft can't hold it up there, okay? And then it'll fall to the ground. But there's a key thing about that updraft. The updraft can't be vertical. So think about if something goes straight up and gets cold and comes back down, they'll cancel each other out, the updraft and down. So you want to tilt. So I do this little experiment all the time to show it. So I'm going to put my mic down again, unless you want to hold this for me. So if you have a piece of hail and you push it straight up, it'll come back down pretty quickly. But the key to getting big hail like this is softball size hail, is to have a tilt to the updraft. So watch as I tilt the updraft, how it stays up there for long enough until it falls. So we'll make it go up, and I'm going to tilt the updraft, and it still stays up there, okay? And there's a very fine line until it falls out. That tilt, it has to be just right where it's enough to keep the current going, but not let it fall out. Now, what hail does, and this is huge hail. This hail is gigantic. It's like softball. This would be 4.5 inch in diameter. This is the biggest hail ever recorded in North Carolina. It's like 4.5 inches, okay? To get hail this big, you need an updraft that's like 100 miles an hour going up to keep that up there. But what's cool about hail, don't ever go out in the hailstorm, because this hurts. Trust me. I've been chasing and been pelted by baseball-sized hail, and it is not fun. But this hail, once it's on the ground, if you go outside and break it open, you'll see rings in the hail. Each ring will tell you how many cycles that it went through. So if there's 4 or 5 rings, it went through that cycle 4 or 5 times. It's like a tree ring. It tells you the life cycle of that hail. So real small hail may not have a ring at all. It might just be one. But big hail, it'll look like a gobstopper on the inside, because it'll have those rings. It's really cool. But hail's the worst thing ever. I mean, I'll tell you a story. When I was chasing in college, we were in the middle of like Wichita Falls, Texas, in the middle of nowhere. And this giant hailstorm, which you're in the wrong spot chasing if you're in a hailstorm. And I was. And the car's getting pummeled. The windows are shattering. The side mirrors are getting blown off. It sounded like someone had a sledgehammer in their car beating it. And The whole time this is happening, it's just deafening in the car. And there's next to us is a field full of cattle. All the cattle just getting bludgeoned, right? They're falling over left and right. And the crazy thing is after the hailstorm was over, I would say about 75% of those cows got back up and walked away. But the crazy thing was it was a rental car, which I highly recommend getting the coverage if you ever do this. But it's funny, a lot of chasers are blackballed by the rental car companies for this reason. But it obliterated the car. It's just a helpless feeling to be in the middle of nowhere. There's no protection, and your car just gets destroyed. And so I hate hail for that reason, because the sound and the helplessness of being in that hailstorm, because there's nowhere to go. You can't drive, you can't see. Out there's very few trees. There's no overpasses. We're in a rural part of Texas, you know, and so it's a horrible thing. And if you have a nice car, there's nothing worse than watching that nice car just get dinged up by baseball or golf ball size hail. So here's a little animation of how the hail works. Hopefully it plays. There we go. So you get that updraft. You get those pieces of ice that keep going up and down, and you see the rings that form as it goes up and down over time. And there's a direct proportion to how big the hail is and the strength of the updraft. So, for instance, the baseball, would be more like in the 70 to 80 mile per hour updraft. And as I mentioned, this is over 100 miles an hour. I don't have my golf ball. Golf ball is close to 50 to 60, but pea-size hail can form like in 35 to 40 mile per hour. So it really can be pretty small hail. And so a good comparison chart, I should say, for hail chart here kind of shows you, if you don't know what a 1/4 inch peas are a good size, 3/4 inch pennies, 1 inch is about 1/4. Ping pong ball is about 1.5 inches. Golf ball is about 1.5 inches to 1.75 inches. So a lot of people don't have measuring tools when you're giving us hail reports. Just tell me what it looks like. I've gotten like crazy things like hen egg, and I don't know. Somebody like gave me one time, there was big hail somewhere and someone said it looked like a CD and nobody knew what a CD was. And so it was really confusing. So something that we can compare it to, usually balls are really effective, or fruit or vegetables, something that's pretty, and also money, coins work really well. And remember that the Weather Service and us, even though if it's not 1 inch, which is severe, I like knowing about any hail, because usually big hail starts small and it gets bigger as the storm develops. So even reporting pea-sized hail is really important. So there's a good example of reporting. Hail spikes on radar are pretty cool. You can obviously we can detect hail in the storm, but what happens sometimes when there's really big hail, because you're talking about big chunks of ice, it'll bend the radar beam and you'll get these hail spikes. It's kind of an artifact of the radar. And when you see them on the radar, it's like a glitch, but it's a glitch that tells you there's big hail in that storm. So it's a really effective tool. So I'm almost out of time. I got 15 minutes. I want to leave time for questions, so I'm trying to blow through this. Okay, so we talked about a lot of severe weather. Probably not the most important thing, though. Flooding is. Flooding is the #1 killer of all weather, right behind heat. My daughter was asking me the other night, I think they're studying disasters in school. And she's like, Dad, what do you think is like the most dangerous natural disaster? And she was trying to say like earthquakes or whatever. And I said, you know what? It's two opposites. I said, it's probably going to be drought and flooding. Because if you think about how many people it impacts, drought impacts agriculture and kills millions of people in Africa, and parts of Southeast Asia all the time. And flooding kills way more people. And then heat's up there. People don't think about heat. Heat waves are really dangerous. We think about all the other severe weather, but those are the things that do cause a lot of damage. So flooding is a big issue. Lightning, even though there's no technical severe criteria for lightning is a really dangerous thing. Every thunderstorm by definition has lightning in it. And one thing, and I know you guys all know this, but I just say this, and I know you're an umpire, so you deal with this. I've been at some baseball games where I've heard dads, oh, I heard thunder. There's no lightning yet. Like, where do you think the thunder came from? Because people don't see the lightning. They'll hear the thunder and go, I didn't see the light. It was just thunder. They're one and the same. Thunder is the sound that lightning makes. So if you hear thunder, there's lightning. It's not one or the other. So the safety thing is, if you hear thunder, you're way too close, because sound travels a much slower and travels shorter distance than light. So if you hear thunder, you're way too close. So the saying is, if you hear thunder roar, go indoors. That's exactly what you should do. The other thing to remember about lightning is it strikes far from the storm. Most people that get hit by lightning happen before and after the storm. You know why? Because when it's raining, people know to go inside. When it's not raining, they're outside, and that's when they get hit by lightning. And the thing to remember, lightning can strike up to 20 to 30 miles from a storm. Because if you think about these storms, we talked about how high they can get. They could be 60,000 feet tall. So if lightning comes out of a 60,000 foot storm down in Pineville right now, and it's clear here at Lower Left, that lightning bolt would come way out here and hit here, and they could be completely blue skies above us. They call that a bolt from the blue, and it happens a lot. So if you see a storm in the distance and you're like, oh, it's clear up here, you still should be inside because that lightning can get you from here. Now, if it's way, way in the distance, like at the beach, when you see them offshore, that's far enough away. But if you hear that thunder, you're way too close. The other thing inside, it is not an old wives' tale. You can get hit by lightning in the tub or shower, okay? Because think about it. The pipes coming into your house go outside into the ground, out to the street. If that pipe gets hit out there, that electricity travels through the pipe, which is full of water, by the way. It doesn't matter if it's PVC. The water still conducts electricity. It comes in and then gets you in the tub or shower if you're connected to that water. So holding the sink or in the shower or tub during a thunderstorm, probably not the greatest idea. And then back in the day when we had video games that weren't cordless, I would tell my kids, you know, that we used to have to we couldn't play our video games when there's a thunderstorm because you were connected to the game console, which was plugged into the wall. Anything that's connected to the electrical lines, which also, guess what, bring electricity in your house, can bring lightning into your house as well. So anything connected to the outside, the scary thing about that is your house doesn't have to get hit, just the lines that are coming into your house. And so oftentimes the power pole or the plumbing or the water main gets hit and the lightning will travel in there. Is it really that common? It's not super common, but it's just another thing that can get lightning into the house. So it's just better, like, you know, stay off of corded devices and stay out of the shower and tub until the storm passes. It's also why if you're a swimmer, why if you have an indoor pool, they still evacuate the pool during thunderstorms for that reason, because if the lightning gets into the water line, the whole pool becomes electrified. So even indoor pools will be evacuated during thunderstorms. So how do you report this stuff? I've told you all this stuff. Well, the best way for us is to use our app. And the reason, and again, it's a shameless plug for our app, but it is a cool feature. We have a thing called the Near Me feature. And what that is if you go to our app and submit something, like a picture or video, it knows your location and it gives us the location of where you are with that picture. Because one of my biggest pet peeves is I'll get a picture or a text or a DM or a tweet, and it'll say, Brad, I got 4-inch hail at my house. And I'm sitting there going, where's your house? I know we all think like we're best friends and I love you, but I don't know where everybody lives. So I need like a town or a neighborhood. And I also would love like a location and timestamp and also like a direction. Like if you know what direction you're looking, like I saw this or this happened on the east, west side, the more information you can give me, the better. But probably the most important thing is just the location. Because it's natural, because you're like, sometimes I'm tweeting back and forth with people and you think, okay, we know each other. And it's like, hey, I just had this. And I'm like, I'm talking to a lot of people. I don't know where you are. Where are you? And so, or if it happened then or 2 hours ago or that kind of thing. So that's important. You can tag us on social media. I'll tell you this, the Weather Service, you can tag them as well. But one of the things that I do, I retweet every damage report or picture I get because I know the Weather Service is following my Twitter feed and they'll see it as well. My goal of resharing everything is not just to reshare it for myself. It's so that other people will see it and then get the information. But if you tag us, you tag GSP on there, you can help us out tremendously. What do we need you to report? Here's the things: wind damage or wind speeds. If you have the ability to give us a wind speed, like you have an anemometer at your house, if not, if you're good at guessing winds, I mean, like, hey, I think it's 30 miles an hour. I mean, I'm not a big fan of that, but one way you can really gauge it is tell me about the branches or what kind of damage it is. Because then I can kind of gauge, well, I know it takes this type of wind to bring down a 2-inch branch, a 4-inch branch. Branches, any kind of structure damage, even if it's like shingles or gutters or like a trampoline or something loose, those kind of things are important. Hail size, any hail size. Are you seeing hail at all? Like I said, just because 1 inch is the criteria, I don't really care. Neither does the Weather Service. Tell us about any hail at all. Flooding. Flooding is a big thing. Is it in areas that don't normally flood? Like, is a street flooded? Is a creek overflowing? These things are really important as well. Remember, the flood gauges are not everywhere. So sometimes the spotter reports are what prompts a flood warning. Oftentimes in Charlotte, it's because we got street flooding that the Weather Service doesn't know about until the emergency manager or one of us says something like, hey, there's water rescues going on, on Queens Road West or whatever. They won't know that's happening until somebody tells them. And they'll issue a flood warning for Mecklenburg County. And then obviously any kind of wall clouds, rotating wall clouds, funnel clouds, or tornadoes. There's ways to report. Obviously, you can tag us or the Weather Service on. And then, the biggest thing, and I should have said this at the beginning, but safety first. I don't want you putting yourself at risk going out there to give us a report. If you can do it from the safety of your house or after the fact or before a storm, that's great. I know, if you're like me, I was a kid, I wanted to go out in every thunderstorm and take pictures of it. But that's the kind of thing I do. So it's okay to do that. Just be safe and be really descriptive of what you're seeing. Think about the kind of report. If you see a lowering, be descriptive, like, hey, I don't know it's touching the ground. Don't assume it is. The thing is, the Weather Service and other meteorologists, we can even a little bit piece of information. It might be a piece along with the radar data or something else I see that could put it all together. And even if you say, I don't know it's touching the ground, but maybe there's somebody on the other side of that tree line that does see it as well and says, hey, it is. The combination of those two reports could tell us that, hey, it's a tornado. So you don't have to assume, if you can't see the ground, just say, hey, Brad, I see a rotating cloud. It's down to the trees, but I can't see below the tree line. That's great. That's all I need to know, because then I might get a report from somewhere else, or I might see on the radar there's rotation. And just the fact that you saw rotation too would be like a light bulb for me, like, hey, this is a serious situation. Just some examples of things you might see. Time of year is important too. A lot of times, if it's a cool day and you're seeing something weird that looks like rotation, I always think we got to think about the environment. Like, what's the environment we're seeing this in? Is a tornado possible? Scary looking clouds are a big thing. I don't mind hearing about scud clouds or even shelf clouds, because they are pretty spectacular. It does tell me a lot of what's going on. And the biggest thing I would say when reporting, if you can, do video as much as possible. I think that would be my biggest thing, because still pictures, sometimes they look awesome, but because there's no movement, I don't really know what's going on. Like, a lot of times I'll get a picture and someone will say, hey, Brad, this looks like a tornado. What do you think? And I'm like, it's still. By definition, a tornado is what? A rotating column of air. But I can't see rotation in a still picture. So it doesn't really help me. So video is great. So I know it seems weird because we pull our phones out all the time. We just snap, snap, snap. Video is probably the more important thing, is video, because it will be more telling. And even time lapses. Time lapses are amazing because you can see motion over a long period of time. And everybody's got security cameras and stuff now too. I have 4 on my roof. They're really just looking at the sky, but I have 4 up there for that reason. It's great because you might be able to check like a camera at your house and see something. And that's another safe way to observe the weather, because you're not outside. You can let the camera put itself in risk. So that's the other thing I do a lot of times. I have those cameras on my roof because I can go check them and not have to worry about being outside. So think about those as well. If you got security cameras, those help out as well. So I'm going to go right to the end because most of this other stuff is just looking at stuff. If you've got any questions or comments for me, I'm always available on social media. As you know, WXBrad on all my social media. This is my personal email address because I'll be honest, I get so much email at work and it's half just spam. I probably will miss an email. So please email me at Gmail. That's a much better platform, especially if it's a storm report, because I'm more likely going to get that in real time. The other thing, in real time, when I'm doing severe weather, I don't mind DMs and private messages, but if I'm in wall-to-wall severe weather coverage, I'm not likely checking that in real time. I'm more likely going to check something that's just tagged or in my feed. And the other nice thing about that is other people that I work with can see that even if I can't, because they'll be following my feed and grab that picture or video. So it helps more people get eyeballs on it, because here's what happens in every time we have a tornado warning. I'll go back after 2 hours of being on the air. I'll take a break, drink, and I'll start going through my Facebook messages, and I'll see a picture of the tornado from 2 hours ago. And I'm like, oh my gosh, why didn't I look? Because I didn't think to go into my messages in the middle of the tornado warning. And I'm thinking, oh my gosh, I wish I had this like 2 hours ago. And it's amazing picture or video. And I'm like, so tagging me or tagging the station or just putting it in the public feed where I would see it or somebody in my staff would see it. Because here's what happens, and James could speak to this. All our producers have learned just to bring up my Twitter feed and my Facebook page and look for stuff that's posted publicly, and they'll grab it and they'll call my ear like, hey, Brad, we just got something tweeted at you. And it'll be like on my Facebook page or something, and we'll use it on the air almost immediately. And the reason that's really important is not just for us. It's because, like I said, the stuff you're sharing with us is going to help somebody else in the next county over seek shelter. Because that video, picture, image is what makes somebody seek shelter or take the corrective actions we need. So it's really valuable. So with that, I'm gonna leave time for questions. Hopefully, got enough. What's that? And Clay, yeah, and Clay's on there too. He's with the Weather Service. I can ask him. It's kind of a delay, but if you relay it to me, I can ask. Yep, go ahead, Rob.
So going back to wall cloud.
Yeah.
When you have a wall cloud, is that just the clouds lowering and looking like a wall, and then how does that form into a funnel, or how does a wall cloud become all that? That's that little in between is where I don't understand.
Great question. So the wall cloud, so the first thing that starts is the whole storm is rotating. Before a tornado forms, a wall cloud is going to be a lowering that drops below the rotating updraft. What makes a wall cloud unique is usually it's the only lowering in the whole cloud. If you see a whole bunch of little fragments and things hanging down, that's probably nothing. But if it's by itself, and sometimes itself will be rotating slowly, it's called a rotating wall cloud. That's how you know it's something different. If it's out of the ordinary, like if I'm looking at a cloud base and it's flat as could be, and all of a sudden, boom, there's this little droppage, and that goes back up and it's flat again, that's a wall cloud. But if it's a bunch of fragments, like it looks like a bunch of teeth or whatever, that's probably less of an issue. So that's what you're looking for. And there is usually some subtle movement to it.
Okay.
That's a good question. That's a great question. I see someone back there. I'm like blinded by this light. Yeah.
I've heard we're like one of the largest metropolitan areas without our own national radar.
Oh, we got a radar question. Cut Clay off. Yeah.
Is that
So
something we should be complaining about, or is it going like the way of 5G with like more smaller stations?
boy, it's only 8:30. This could have been a whole other topic. So yes, to answer your first question, we are the biggest metro area in the U.S. without a radar within 50 miles of the city. And I'm talking about next-rad Doppler radar. It is a big problem. We've been trying to fix it for like 15 years, trying to get the government to install one. Trust, it's been horrible. I feel like we've jinxed every politician we asked to help us with this, lost their election. So I don't know, but we do have some new people on board that are kind of getting on board, and it's actually bipartisan, believe it or not, support to help try to get a radar gap. Now, the problem is, in the past, the National Weather Service, and I won't speak for Clay, but I will in this point because I kind of know, the problem they were worried about was like legislation to say put a radar in and not funding for that, and then having to draw funding from their already tight budget. And then that meant laying people off or it's kind of like, hey, we built the radar, but guess what? Now we have less people to look at the radar. It was like a catch-22. The goal that now is that we've been working with the state emergency management is to try to build a private-public partnership where we would use either a grant or even private donors from corporate people in Charlotte to build the radar and have the emergency management of North Carolina run it. And then the data would be given to everybody, including the Weather Service, TV stations, you on your phone app. Everyone would be able to look at it. This has happened in other parts of the country. In fact, Durant County, Oklahoma just put one in. Their county emergency manager bought it and allows everyone to look at it. So I think we're getting close, but it is a frustrating thing. We do have a smaller terminal Doppler radar that the FAA put in for the airport to look for those downbursts so that airplanes could take off and land at Charlotte Douglas. It's a weaker, smaller radar, but right now it's kind of a Band-Aid for a bigger problem. So I'm hoping that in the future we'll have a problem solved. We're getting close. There's legislation in the state right now to help get this enacted. Jeff Jackson is involved, Ted Budd. I said, it's like, there is a lot of people that, like I said, across the political spectrum that are really, they know it's a problem. It's an easy sell to anybody because weather safety is so important. It's one of the few things that I think people want to spend tax money on because it helps us and it saves lives and it's really important. So I hope we're close. Good question though. Yep.
Have a tornado without a severe thunderstorm environment?
It does happen. I've seen it maybe 2 or 3 times here. And usually it's because we've had 2 air mass thunderstorms and their outflow boundaries have collided. And we've seen quick spin up tornadoes. So it's rare, but it does happen when you have sometimes colliding boundaries like that. And those are the ones that really catch you off guard because you're like, what do you mean? I'll get a report of a tornado. You're like, we're not even in a severe climate. And then you look at the radar and you see these 2 outflow boundaries collide, and sometimes a quick spin up will happen. So it does happen. But usually it's pretty rare. We usually have at least a severe thunderstorm warning or 2 before we get a tornado. And the thing is, there's not always a tornado watch before a tornado warning. Sometimes the environment just comes together and we get severe weather. Yep.
Why do we need milk for hurricanes?
I don't know. That's a good question. I don't even know why we need milk and bread for anything. But apparently every storm, you got to go buy it all and the toilet paper. I don't know. But that seems to be a common thing. The thing about water around here, I remember when the hurricanes, everyone's buying bottled water. I'm like, the water's not going to go out. And the other thing is, your water works now. Why don't you just fill up jugs instead of buying bottled water? It's people do weird things. What happens, and that's a psychological thing. People feel like they have to do something. So buying bulk items feels like you're doing something, when in reality, you're just buying stuff and it's not really helping. I'd much rather people have a plan and have a kit. Like for me personally, yeah, having some canned food and stuff around. I've been in Charlotte for 20 years. I haven't lost power for more than a day. Have never lost water. Some of these things, it's short term. You need 2 to 3 days supply. And most of you probably already have that in your house. You're not going to be stuck at home for like 2 weeks. That's pretty rare. We're not at the coast where that's going to be a much bigger issue. But that is kind of a silly thing. There's other ways to prepare. Yep.
An online viewer wants to know, why is it so hard to confirm tornadoes?
Why is it so hard to confirm tornadoes? A viewer online. It's a good question. Like, what do they mean by that? Like confirm?
I'm going to guess maybe see on radar.
Oh, okay. Like in real time. Most likely it's because we don't have spotters in that area. It's at night or the visibility is bad. A lot of times radar data is lacking, so you don't know it's on the ground for sure. So yeah, confirmed tornadoes are kind of hard in real time. And the other thing I always have to confirm to people is that the point of a tornado warning is to forecast the tornado before it happens. If we waited to warn until the tornado touched down, that'd be kind of too late. It's like you got to give people a heads up before it happens. That's why the false alarm rate is so elevated, because the goal is to give you a heads up. I always equate it to like a cancer diagnosis. How many times do you go get something checked out just in case? And most of the time it's going to be benign or not a big deal, but it's one of those things you got to check out anyways, because it could be. So that's what we do with tornadoes. It's like, you better just err on the side of caution instead of just saying, oh, well, it might or may not be. We'll wait and find out. It's one of those things. It's a life and death situation. So you're going to take the chance and just put the warning on. Good question, though. Yep.
Why is it so difficult to see, like tornadoes seem to happen at night here as opposed to the Midwest? It's like during the day you can see them.
That's a very good observation. Believe it or not, I am pretty sure still North Carolina leads the nation in nighttime tornadoes. We get a lot of them around here. And it just so happens our environment here tends to be what we call high shear, low cape. Remember those ingredients I talked about, a lot of wind shear and a lot of thunderstorm fuel? Well, one way you can overcome a lack of thunderstorm fuel is to have like 5 times the amount of wind shear. It's like you overwhelm with wind shear. And that happens at night, because at night, think about it, there's no heat. So you don't have a ton of fuel, but the wind shear can be so intense here that we'll get tornadoes in the darkness of the night. And for me, that's literally a nightmare for me, because it's impossible to warn people, because one, they're not paying attention. They're not expecting them. They're asleep, and nobody, even spotters, you can't see them. So those are the worst ones. Those are the most difficult things. And I've had, I remember in 2012, a tornado touched down in Reedy Creek, 2:36 in the morning, BF2. And I remember doing a story about the family that was impacted. 2 kids were actually blown onto 485. They were pushed out of their house in their beds. They were fine. They were no injuries. But the story blew me away because we knew there was severe weather that day. They had all slept downstairs because they were worried about severe weather. They got to 11 o'clock at night and they thought, oh, it's night. It's not going to happen. They went back upstairs and went to bed thinking it was over. And the storm hit in the middle of the night. And to me, that was like a case of like, that's human nature. Like, it didn't happen during the day, so it must not be happening. I'm going to go to sleep. And 2:36, they get hit by a tornado. So that does happen a lot. That is a very Carolina specific threat. And it happens because of the environment that we have in the Carolinas. Yep.
What causes that freight train sound?
So the freight train sound, I would argue that it really isn't. Having chased tornadoes, I don't think it sounds like a freight train.
Okay, but it's definitely a sound.
Yeah, I think it's more of like a jet engine or wind, or like, have you ever been to like a big waterfall? That roaring sound?
We were in Florida. We were in a vintage store.
Yeah.
We heard the sound.
Yeah.
Half the power went out in the building, and we just pulled out our phones and started flipping through the records again.
Yeah.
It was a noise, though. It was like
Yeah.
audible.
No, it is a noise. Trust me. Yeah, it is like a roar. But I think it's more if you've been to like Niagara Falls or big waterfall, or even like the sound of big jet engines. It's a wind sound. The thing I associate with a freight train, and I lived near train tracks growing up, is that of the going over the tornado does not sound like that. It never has a horn either. So I always think it sounds like more like a wind or a jet engine or a waterfall. But that's because there's so much air getting pulled in and the wind sound work around. And then when it picks up debris, you've got the sound of all that stuff getting blown around. So it is a deep roar. The big tornadoes have a very deep sound. You can feel them too, the vibration and the pressure fall. The big tornadoes definitely are not. I mean, they are scary. They sound like they're roaring at you. Yep.
What is the longest or biggest tornado ever?
Ooh, that's a good question. So the strongest tornado that we know of, there's kind of a tie. We think it's the Moore 1999 tornado, Moore, Oklahoma. It had winds of 319 miles per hour. But we think the El Reno, Oklahoma tornado might have surpassed that because we have Doppler data that shows it might have been even stronger. The El Reno tornado was the widest tornado, 2.5 miles wide. And we think that might be the widest. The longest track tornado is still the tri-state tornado, which went over 3 states early in this century. But the Mayfield, remember the Mayfield, Kentucky tornado that happened in December, was it 2 years ago and 3 years ago now? That traveled almost the same distance. So some of those long track tornadoes are just crazy to think about. But that's why tornadoes have the strongest winds on the face of the earth. We've been able to detect the strongest winds recordable in a tornado. And mainly that was from radar data bouncing off of debris that was spinning around at that speed. It's pretty crazy to think about that. That's probably, you bounce the radar beam off of a 2x4 or shingle going at 319 miles an hour. It's just crazy to think about how fast it rotates. Yep.
Online viewer wants to know, why do squall lines come up I-85 come to Charlotte and then split in half?
That's another common thing. So I get that quite a bit. And I almost brought that up in the squall line thing. A lot of times squall lines, remember about our radar coverage talk, the radars are only in specific locations. So what looks like splitting up and getting stronger and weaker, maybe that it's going closer or farther from the radar. It's not necessarily doing that in real time. The other thing is sometimes it's just timing of the day. If a squall line is in the peak heating of the day and it gets to us and it's after sunset or near sunset, it's losing its energy. So it's going to fall apart. It's like that. It's like the thunderstorm thing. Is it at the mature stage or dissipating stage? And the other thing is, let's be honest, we're all very biased about where we live. We only notice things that happen to us. We don't notice that it happens in other spots because we don't live there. And so we only tend to remember the stuff. And we have a lot of confirmation bias, basically. It's a good question, though. Yep.
We had some friends in Fort Lauderdale that were recently affected by the flooding there.
Yeah.
Do you think this area is like susceptible to flooding in that way, or is it just
We are. If you were to ask me the biggest thing we're susceptible from in climate change here in Charlotte, it would be flooding. And it's a twofold reason. One, we have seen heavier rainfall events in Charlotte, and two, because of our growth. We are growing rapidly. I don't think anybody would argue that. And that causes a lot of problems. One, it's more impervious surfaces, so the water runs off quicker. It also means our stormwater system, they do a great job. They can't keep up. The pipes that are moving stormwater that were built in the 50s and 60s cannot handle rainfall from 2023. So it's more of an infrastructure issue where they didn't think they would ever have to do 2, 4, 5 inches of rain in 3 hours. They were built for like 1.5 inches. So to me, that is a big problem. We are already a flash flood prone city because we have a lot of creeks and streams. There's a lot of elevation change in Mecklenburg County. We have so many streams and creeks. If you think about Uptown, the reason it's called Uptown, it's just not a marketing thing. It's built on a ridge between Irwin Creek and Sugar Creek. Trade and Tryon is the highest point in Uptown Charlotte. So if you've ever walked or rode your bike up there, you don't have to, I can tell you, it's uphill to get to Trade and Tryon, and then it's downhill on the other side. That water runs off into those creeks quickly. And so when we get heavy rain over urban setting like this, flash flooding is going to naturally be our biggest issue. So I do think it is going to be a big problem. In my time here, that's the one thing I've noticed is that, 4 or 5 inch rainfalls are just like more common, and the 1 inch and 2 inch rainfalls are becoming more and more common. So flash flooding is going to be a big issue here. That's a crazy event. That's 25 inches of rain in one day. I mean, insane. And when their problem is you're so close to the ocean already, there's no elevation. So the water just sits there. You're too close to the ocean. So it just sits there, and it takes days. That's why it took days for it to drain. And Fort Lauderdale Airport was closed for so long because the water just had to slowly seep away instead of drain. It's a good question though.
I have the same question.
Yep.
I've heard Charlotte over the years bought a lot of the housing like in low-lying areas.
Yeah, we're a model for doing that. Yeah.
And I've seen like you walk near Sugar Creek after a large rain and you see the mud.
Yeah.
Are we doing a good job? Are we doing the bad
We're doing
job?
much better than a lot of places. The one thing at Charlotte is kind of like I said, leads the nation is we bought a lot of the land in areas that used to flood. The little Sugar Creek, most of the greenways here are built on land that is a floodplain anyways. The reason the greenway is there is to enjoy the greenway, but also to let that area flood and not flood people's homes. That's where we go. So a prime example of this is behind a Park Road Shopping Center.
Yeah.
If you've been behind Park Road Shopping Center, there used to be homes all back there. They bought them all up and made it into a green space so it could flood naturally and not flood homes. So the city has been doing more and more of that. The problem is, if you have a house and your house is just reassessed, it's hard to buy property in Mecklenburg County because it's super expensive. And for them to buy, they used to be able to buy a lot more. Now they have to give fair market value. So to buy more of that property, it takes more time. But they do spend a lot of money doing that because in the long run, it's better to buy that property and let it sit, bank it, than replace and fix that home 4 or 5 times every decade because of flooding. Ends up costing the taxpayers more money in the long run. So yeah, we do a good job. Question?
There's more so on tornadoes.
Yep.
Could you explain like the pressure drop, like as tornadoes are coming?
Yeah, so the pressure does drop dramatically. In fact, last night I was looking at the mesonet in Oklahoma. The tornado came within, I think, a half mile of the Shawnee Airport, and their pressure dropped like crazy low. Because what's happening, if you think about what a tornado is doing, it's sucking air up into the storm. It's when you suck the air up, I think you don't think about this, the pressure, it makes the pressure fall dramatically. And that's what's creating the wind. So you're pulling so much air off the surface that air is rushing in to take the place of that vacuumed air, basically. And so that pressure will fall dramatically. Your ears will pop. It will be really traumatic. Every time you've been near a thunderstorm like that, the one that went through our backyard, that's the thing my wife said that her ears hurt so bad when the tornado passed through the backyard because they popped because of how low the pressure was. But you're evacuating so much air from the surface of the earth that it's lowering the pressure, because that's what pressure is. It's literally less air over you than when there's high pressure, which is a whole bunch of air. So when you get those big storms like that, there's very little air above you and it creates a low pressure. That's a good question. Yeah, that's a thing a lot of people notice. A couple more questions and we're almost out of time. Any more? All right. So if there was a question I didn't get to, more than welcome to DM me or email me. I'd love to answer them at any time. Thanks again for coming out. I'm going to stick around for a little bit. So if you want to come up and say hi, take a picture, or ask me something not in front of everybody, I can do that as well. Thanks again for coming out, and thanks to Lower Left for hosting us again. Okay. Thank you.
Where'd you get the sick lightning shoes?
Brad, can you see if Clay can hear you?
Clay, can you hear me?
Yeah, I can hear you.
All right, go ahead. So Clay is going to say something real quick from the Weather Service.
Hey everyone, I'm Clay Cheney, meteorologist here at the National Weather Service office. Just wanted to say that was a great presentation by Brad. Just wanted to follow up just really quick in terms of what we're looking for in terms of spotters. So of course we want you to report any types of weather, severe winter weather, flooding, those sorts of things, as Brad had mentioned in his presentation. The best way to get that to us is to submit a report. We have a website that you can go to. You can also go to our Facebook page, Twitter page. You can also send us an email. I'm guessing the email maybe could be gsp.spotter@noaa.gov. You can also use your mobile app as well for MPing alerts. So MPing alerts, if you have radar scope, or if you download the MPing app on your smartphone, you can actually give us reports that way as well. So yep, thanks for joining Brad's Spotter Talk. It was a really good one, and I know down at the bottom left there you can actually see the form that you can fill out to actually get certified as a spotter. We do not do certifications for spotters. We do spotter IDs now. So whenever you apply, you will get a spotter ID, but you will not get a certificate. If you get our contact information and you do run into a report that you want to give to either Brad or us here at the National Weather Service office, we definitely appreciate that. And we also, as Brad had mentioned in his presentation, to give us as full description as you can. These help us to verify our alerts that we put out. So the severe thunderstorm warnings, tornado warnings, and such, those help to verify. And like Brad had mentioned as well, the people downstream or upstream from those warnings also get the spotter reports, and they're able to kind of take heed and rely on those reports and let them know that the storm that's ongoing can impact you and possibly will impact you if you are in the track of it. But thank you guys for joining the Spotter Talk, and with that, I'm out unless there are any questions.
Thanks, Clay. All right, guys. As you can see, GSP's website is pretty easy. Go to weather.gov/GSP. There's a lot of great information there if you want to contact them, if you need a spotter ID as well. They're great partners with us. We work in tandem with the Weather Service, like Clay said. Clay's actually up from this area, so he grew up in, I think grew up in Cleveland County, if I'm not mistaken. So Clay's from this area. So we like working with those guys, and Trish down there, their MIC is great. So thanks again to Clay, and thanks everyone coming out today.
Where do we get those sick lightning shoes?
Oh, these are Brooks.
We really enjoy having him every time. It's our second time he's been here, and maybe we'll get him again. But thank you again, Brad. Thank you, everybody else.